Hi there, folks. We're looking at question 24 on the 2005 Fermat. We're going to skip the slower intro, and we're just jumping right into it. The arithmetic sequence A plus D, A plus 2D, A plus 3D, all the way up to A plus N minus 1D. So this is the first n terms of an arithmetic sequence. So we have an arithmetic sequence that has the following properties. When the first, third, fifth, and so on, so then seventh and ninth, assuming we go up that high, are added up to and including the last term, the sum is 320. When the first, fourth, seventh, and so on terms are added up to and including the last term, the sum is 224. What is the sum of the whole sequence? Okay. Now I'm a little off put by the wording. Do they mean that the last term is both an odd number and a number that when I divide it by 3 gives us a remainder of 1? Or do they mean the last term in that first, fourth, seventh progression? That sort of thing. So that's what I sort of have to ask myself. And I'll make that decision as we go if I reach a roadblock. But I'm going to start not assuming as much as I can. So we have a sum, and we get 320, and then we have a different sum, we get 224. Alright, well, let's figure out how to add up terms in an arithmetic sequence, provided they have a bit of a progression. So we'll take a look at the first term by himself is a. If I add on the third term, we have a plus 2d. If I add on the fifth term, we have a plus 4d. Seventh term would be a plus 6d. And if we keep adding these, if we add them up, we'd have a, we'd have 2a plus 2d. And then if we added on the fifth one, we'd have 3a plus 6d. 4a plus 12d. I'm not quite noticing a pattern just yet. The ninth term would be a plus 8d, so then it would be 5a plus 20d. Okay, so sum of odd terms is here. So here's my pattern. Sum of the first k odd terms is you'll have k a's, because each one introduces an a, plus, and then we'll have k times k minus 1 d. So we know this has got to be equal to 320. Okay? So, for instance, then that means that k is a factor of 320. Now, we could go ahead and prove this if we really wanted to. It's really about is the sum of 2 plus 4 plus 6 plus 8 and so on equal to k times k minus 1. And you could show that without too much difficulty. 2 plus 4 plus 6 plus all the way up to 2 times k minus 1 is what it is. Well, that's 2 times 1 plus 2 plus all the way up to k minus 1. And there's a formula for the sum of the first few natural numbers. The first k minus 1 natural numbers is k minus 1 times k minus 1 plus 1, or just k over 2. So this is k minus 1 times k. And this isn't that hard to show. It's probably something you should know if you're trying question 24 on the Fermat. And if you didn't know it, that's something you can look it up. Sum of the first n natural numbers. Triangular numbers is also another great term. So we could realize that without too much difficulty. How about if we summed up every third term? So we start with the first. What does the fourth term look like? What does the seventh term look like? And I'm noticing there's some overlap here. What does the 10th term look like? The 13th term, and so on. So we'd have a plus 3d, a plus 6d. Ooh, so now I'm adding up 3 times the natural numbers. A plus 9d, a plus 12d. So our sum would be a, 2a plus 3d, 3a plus 9d, 4a plus 18d, 5a plus 30d, so in general, the sum of we won't use k again, I'll use m, of m third numbers. It's the odd numbers worked out so well, but m remainder when divided by 3 is 1. That doesn't roll off the tongue like odd does, but terms is, so we'll have MAs, that's pretty quick to see. Then we'll have 3 over 2 m times m, so m times m minus 1 d. And again, showing this term is just as simple as saying, you know, it's 3 plus 6 plus 9 plus 3 times m minus 1. So that's 3 times 1 plus 2 plus all the way up to m minus 1. And we just talked about this. This is 3 times m minus 1, m minus 1 plus 1, all over 2. So 3 halves m times m minus 1. Alright, and we know that this is supposed to be equal to 224. Okay. So great, we understand how we're adding up the terms. I want the sum of the whole sequence. What can I do? What to do. So, this isn't quite enough information to get A and D right away. Yeah, so the two formulas we've got, so k odd ones would be ka plus k times k minus 1d, and m odd ones would be ma plus 3 halves m times m minus 1d. So I know the first one's 320 and the second one is 224. So now, I think I have to use the fact that they say last term to actually mean the last term. Because then we can get a relationship between A and K. So I might say something like, per the wording of the problem, the last one in my odd numbers list is, oops, it's got to be 2 times that, doesn't it? A plus 2 times that is the same as the last one in my 1 mod 3 list. So then 2 times k minus 1d is 3 times, so we just subtract a from both sides, divide by d on both sides. 2k minus 1 is 3m minus 1. And then, so 2k minus 2 is 3m minus 3. Bring one of the ones onto the other side. So 2k is 3m minus 1. Or k is 3m minus 1 all over 2. So, I think we can sub that in for k. K minus 1 would then be 3m minus 3 over 2. So we'll sub that into equation number 1 and get equation number 1 prime. 3m minus 1 over 2a plus 3m minus 1 over 2, 3m minus 3 over 2, d is 320. I'm going to multiply everything by 4 to get rid of the common denominators. So 6m minus 2a is 3m minus 1, 3m minus 3, d is 320. Okie dokie. What else? What else can we do here? Oh, it's not 320 because I multiplied it by 4, so it'll be 1280. Alright, but it's still, we still have this 3 unknowns and 1 equation. Or sorry, 2 equations, 3 unknowns, and that's not a good recipe for solving things. But maybe I don't need to solve it. Maybe figuring out k and m was a bit of a wrong turn. Because what is the sum of the whole sequence? Right? So let's ignore what I just did. What is the sum of a whole sequence? Right, we'll have n a's, and then we'll have n times n minus 1 all over 2d. So this is how we add up an arithmetic sequence, and we want this value. And the last term there is n minus 1, and that's the same as 2k minus 1, and that's the same as 3m minus 1. So, where can we go from here? N minus 1 has got to be a multiple of 6, certainly. I don't think that's going to help me, though. But this relationship might clear things up enough to do something. Not sure what yet. So I want NA plus n minus 1 over 2 times d. And is there some way I can fiddle with these two known values and get that? Well, I can get k in terms of n and m in terms of n, and then convert those two previous equations into ones involving n, and maybe that might make things clearer. So n is 2k minus 2 plus 1, so 2k minus 1. N is also 3m minus 3 plus 1, or 3m minus 2. So k is n minus 1 over 2. M is, plus n plus 1 over 2. And m is 3 plus 2 over, or n plus 2 over 3. Okay, so I know 320 is Ka plus k minus 1, d. But then that means it's n plus 1 over 2a plus n plus 1 over 2, n minus 1 over 2, d. 224 is ma plus 3 halves m minus 1, d. But then that means it's n plus 2 over 3a plus 3 halves n plus 2 over 3 n minus 1 over 3 d. So now, where do we go from here? So I'm going to multiply the top equation by 2 and the bottom equation by 3. So 640 is n plus 1a plus n plus 1 over 2 n minus 1 d. So now I've got my n minus 1 over 2 d. I just have an n plus 1 sticking around as well. And then multiplying 224 by 3, we get 672 is n plus 2a plus, if I multiplied it by 3, we'd have 3 over 2. Oh, the 3's are going to cancel out here. And we'll have n plus 2 over 2 n minus 1 d. I'm going to shift where my over 2 is. So n plus 1 n minus 1 over 2 and n plus 2 n minus 1 over 2. So we're very, very close. We've got exactly the thing we want, except where we want n's, we've got n plus 1's and n plus 2's. So is there a way to get rid of this? So this is the sum we want, and this is plus an additional a and an additional n minus 1 over 2 d's. And this is the sum we want plus 2 additional a's plus 2 additional n minus 1 over 2 d's. So, if I say if S is NA plus N minus 1 over 2D, and I don't know, capital D is A plus N minus 1 over 2D, we want S, and we know 640 is S plus D, and 672 is S plus 2D. So D must be 672 minus 640, which is 32, and so S is 640 minus D, 640 minus 32, 608. Is 608 one of the answers? Yes, it is. It's right there in the middle, C. So it turned out there was a hidden arithmetic sequence here inside our arithmetic sequence. And that's not so bad. I actually liked the way that turned out. I had a little bit of a bad detour when I was trying to work out k's in terms of m's. That was the wrong way to go. And things were getting into a convoluted mess. And so that's when I decided, no, let's go back and shoot for figure out what we're actually shooting for. Because I had I could get m's in here, but I had 3 unknowns and 2 equations, and that's not a recipe for being able to say A is this, D is this, M is this. And so then it had to sort of be one of those questions, and I've mentioned this from contest to contest. There are often questions where, they ask you to do something with an x and a y. Figure out 2x plus y. But they don't give you enough information to get x and y separately. But there is a way to get the 2x plus y that they're asking for. And this is exactly the sort of situation we're talking about. I have no idea what n is, or a is, or d is. I didn't need to. But I still got my 608. So join me for the last question on this contest, and then we'll be done the multiple choice contests for 2005. So join me for question 25 in the next video.